The study helps to confirm a 2006 finding that 5 industrial chemicals have been identified as neurodevelopmental toxicants. The study also adds more chemicals to our watch list. Joining us is the author of the new study, Phillipe Grandjean, an adjunct professor of environmental health at Harvard School of Public Health. Welcome, Dr. Grandjean.
Thank you.
How many are at risk of developing a cognitive disability due to exposure to these sets of toxins?
This is a global problem. So I would say basically all children, all pregnant women in the world are at risk to some degree. We are all exposed to industrial chemicals, some of which can damage brain development, and many of which we don't really have any information about so far.
Now, when you say we are all at risk, are we all equally at risk, or are we seeing disparities amongst gender, race, or other categories?
It's true that there are variations in the degrees of exposure. There are, for example, some developing countries with just enormous exposures to lead and pesticides, while it may be less in at least some Western countries. I would say it's hard to determine at this point because we just know a small number of chemicals that represent the tip of an iceberg. And those chemicals, that's where we have the good information about whether or not they cause damage to brain development in the fetus and in small children.
Now, when we're talking about these chemicals in developing countries or here in the United States or in developed countries, what are we talking about? Are we talking about, say, the pesticides that in the United States were declared illegal and yet were sold to developing countries? Are we talking about the much more powerful pesticides which are being used nowadays because organisms are becoming resistant to the present herbicides?
It's actually, potentially at least, all of the above, all of what you're suggesting. For example, DDT is one of the compounds where we now have solid evidence that it's damaging brain development. But DDT is no longer used in most of the Western world, but it has been taken up again for malaria control. Likewise, the other pesticide where we have detailed information, chlorpyrifos, it's an organophosphate pesticide. That substance was originally used in the U.S. For control, for example, of cockroaches in buildings, in residential buildings. That's no longer legal, but it is still being used all over the world to protect various kinds of crops, grapes, for example. And since grapes are then exported to, say, northern countries that are not using it or where it's banned, this substance will enter the food from residues of the pesticide that originate from warmer countries where this pesticide is being used extensively.
Now, we know it's not just pesticides. I remember fairly famously when I was growing up, there was a lot of alarm about asbestos in playgrounds, about lead in paint, and other substances like that that are common in very urban areas. What are some of the other of the large 5 that we should be worried about?
Well, lead is certainly the paradigm of toxic substances that can damage brain development. And yes, old paint is a continuous source. We've gotten rid of lead in gasoline, but there's a lot of pollution out there. And we can see that the current exposure in the United States, even though it has decreased substantially, that exposure is still associated with deficits in brain functions in children, associated with their exposures in early life. And if you go to Eastern Europe, you will find that the lead exposures are much higher than in the U.S., and there are certainly developing countries with tremendous problems. Mercury is another of the traditional neurotoxicants. It comes from fish. And if pregnant women are eating the wrong kind of fish, that is the large predatory fish species such as tuna and swordfish, then the woman will accumulate this in the body and will share it with the fetus, and it goes right into the fetal brain. And we know that even current exposures in the United States, particularly in fish-eating pregnant women, those levels are capable of causing adverse effects so that, the children are not getting sick. They're not getting autism or ADHD, but they will be a little slower. They will have a poorer attention span, perhaps a lower IQ. And because the brain is so important for all of us, the brain is the organ that makes us who we are, then I would think that any mother would say, I'm not willing to give away some of my child's brain functions. Even subtle changes in brain functioning are very important. The child may be slower at developing. The attention span may not be as good as it should be. There may be a loss of IQ points. And, this does not result in a diagnosis of ADHD or autism or something like that. And so this is not readily diagnosable. But if you look at a whole population of children, then there's a shift of the distribution so that there are fewer smart kids and there are more kids who are having problems. And all of them are functioning at a lower level than they could have been. And I would think that every single mother in this country and certainly internationally, they would not, on behalf of their kids, donate away IQ points or any functional reserves just because there's some pollution in the food, in the air, in the drinking water, in the house dust, or wherever it comes from.
Now, we've talked about lead and we've talked about mercury. These are fairly well-known substances which could have adverse effects. What are some of the other ones that produce different responses? What about manganese, for example?
Right. Manganese is an example, and fluoride, and there's toluene, a solvent, and there are the brominated flame retardants that are being added or have been added to textiles, to tents, sleeping bags, sleepwear, furniture, etc. All of those, they are in our drinking water, they are in our house dust, they are in the air pollution. We all exposed to them. But I sort of have a hesitation to specify how one could avoid those chemicals, because in my mind, this is just the tip of an iceberg. And if I recommend to avoid certain types of products and to use something else instead, this may not be correct, because the alternatives may contain some other chemicals that we perhaps in the future will be able to document also have adverse effects. So the real severe problem here is that there's no country in the world, certainly not the United States, where we are testing industrial chemicals to determine if the products are safe for pregnant women and for children with regard to that extremely vulnerable organ, the developing brain. We're not doing that. And since the United States is now considering to develop a new legislation on chemical safety, and the legislation in the EU is being updated, and there's new legislation in Korea, I think that there are hopefully, that's what I hope, there are signs that the legislators in different countries may be understanding that we just cannot continue this way and rely on ancient legislation from the 1970s where we did not know these perspectives.
Now, in your study, you looked at several of these items. Manganese you associated with diminished intellectual function and impaired motor skills. how strong was the correlation? How confident are you in it? And will we get to the point, can we get to the point where we can say there is a causal link?
Right. This is always a judgment call, and of course the evidence is so much stronger in regard to lead and mercury, but we decided that the associations for manganese and a few other compounds, those have been replicated. They have been seen under different circumstances with follow-up studies of children, and other causes have been taken into regard appropriately, and we thought we would be able to rely on those studies simply because there was more than a couple, and also they were plausible because of the experimental evidence that these substances in animal models, in mice and rats, etc., that they are actually toxic to brains and to brain development. So I think the evidence is pretty strong, but I would say it's only the tip of the iceberg, and therefore, in my mind, the major paradigm shift is not associated with us pinpointing this compound or that compound and not a third one as being risky to brain development. I think that what we are pointing out, and what is most important, is that we're saying the human brain is such a complex organ. That organ is uniquely sensitive to toxic chemicals. And since a very large number of industrial chemicals, they can make it from the mother's blood stream through the placenta into the fetus and into the fetal brain, and those compounds can also penetrate into the brain of small children, then we are essentially exposing a crucial part of our organ functioning to chemicals that can potentially damage the brain cells. And the trick is that you only get one chance to develop a brain.